Question number 106. Tricarpillary, syncarpous, trilocular, superior ovary with axile presentation is found in first option mustard family, second grass family, third lily family, fourth potato family. Tricarpillary, syncarpous, trilocular, superior ovary. In case of mustard family, that is Brassicaceae, the ovary is bicarpillary and unilocular. So this option is ruled out. In case of grass family, it is monocarpillary and unilocular. But in question it is asking about the trilocular. So this option is also ruled out. In case of potato family, the ovary is bicarpillary and bilocular. So this option is also ruled out. In case of lily family, the ovary is tricarpillary, trilocular, syncarpous, superior with axile presentation. So the correct option for the given question is option number 3. Let's move on to the next question. Question number 107. Select incorrect feature or features from A to D regarding collenchyma tissue. A. Living mechanical tissue. B. Absent in monocots. C. May be photosynthetic. D. It is lignified. First option only C. Second only D. Third both C and D. Fourth both A and B. You have to choose the features that are true for the collenchyma tissue. Collenchyma tissue is the simple tissue which is living mechanical tissue. So it is living mechanical tissue. Yes, it has protoplast. At the maturity it is living. It provides mechanical support, hence it is mechanical tissue too. It is absent in monocots. Yes, collenchyma is absent in most of the monocots. It cannot be seen in monocots. It is absent. Maybe photosynthetic. Yes, it can be photosynthetic too. It is lignified. No, collenchyma is not lignified. It has thickening, but that thickening is of hemicellulose and pectin, not of lignin. So it is not lignified. Only D is incorrect. So the incorrect feature is only D. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 108. Exact type of arrangement of primary xylem is seen in first option root, second monocot stem, third leaf, fourth dicot stem. Before going into the details of this question, we should know what is exact type of arrangement of primary xylem. Primary xylem, that is the xylem which is present in the early stages of a plant, it is the primary xylem. It can be exact or endark on the basis of position of protoxylem. The very first formed xylem is called the protoxylem, and after that protoxylem, the xylem formed is called metaxylem. So primary xylem has protoxylem first and then metaxylem. So what is exact type of arrangement of primary xylem? When protoxylem is present towards the periphery, as in this figure you can see, this is protoxylem as it is smaller, as its vessels are seen smaller. You can clearly see protoxylem towards the outer side, and this is the metaxylem which shows wider cavities. It is present towards the center. So when protoxylem is present towards the periphery and metaxylem towards the center, it is called exact type of arrangement which is seen in roots. In all roots, whether they are monocots or dicots, they have exact type of arrangement of primary xylem. But in case of stems, it is endark type of arrangement where protoxylem is present towards the center and the metaxylem is present towards the periphery. Whether they are monocots or dicot stem, you will find a dark type of arrangement in stems. So these options are ruled out. In case of leaf, the arrangement is again in dark. So this option is also ruled out. So the correct option for the given question is option number 1. Let's move to the next question. Question number 109. What is incorrect for companion cell? First option, it is specialized parenchymatous cell. Second, it helps in maintaining the pressure gradient in the sieve tubes. Third, it does not retain nucleus throughout the life. Fourth, it is absent in gymnosperms. What are companion cells? If you see the components of phloem, in angiosperms it has 4 components. These are called sieve tube elements, companion cell, phloem fibers, and phloem parenchyma. So phloem is a complex tissue which has 4 components: sieve tube elements, companion cells, phloem fibers, and phloem parenchyma. These companion cells are nothing but specialized parenchymatous cells only. So this option is true. Second, it helps in maintaining the pressure gradient. Yes, during the phloem transport, companion cells help the sieve tube elements to maintain the pressure gradient. So this statement is also true. Companion cells do not retain nucleus. This statement is wrong, as sieve tube elements, they lack nucleus, but companion cells have nucleus which regulate the functions or activities of the sieve tube elements. So they have nucleus. Fourth, it is absent in gymnosperms. This is also true in case of gymnosperms. Companion cells are absent. Instead, they have albuminous cells at the place of companion cells. So the correct option for the given question is option number 3. Let's move on to the next question. Question number 110. In maize seed, the outer covering of endosperm separates the embryo by a proteinaceous layer called, first option, coleoptile, second, aileron layer, third, scutellum, fourth, coleorhiza. See here, this is the figure of maize seed from your NCERT. You can see here, this layer is a part of endosperm and it is called the aileron layer. So this is the layer which is the aileron layer. It is proteinaceous in nature and it is the outer covering of the endosperm also. So the outer covering of the endosperm which separates the embryo by proteinaceous layer called the aileron layer. So the correct option for the given question is option number 2. Let's move on to the next question.